old, or something like I paid 20 riyals.
Unit is different.
Okay. The units are different. What else?
Different measure.
Okay. Okay.
Different quantity.
Could be for anything.
Okay. Let's do one more example. What about when I say the temperature is 20 degrees Celsius, and when I say the wind speed is the wind is blowing at 20 kilometers per hour.
Temperature have no direction.
Good.
And the wind have direction.
Good. You have touched on a very, very core point. At the very base, at the very core, these two types of measurement have something different. Yes, they're different measurements, they have different units, but there's something very core about them that is different. One of them is happy with just a number and a unit. So, and that is what we call a scalar, a number plus unit. When I tell you you are 20 years old, you are happy with my sentence. When I tell you the temperature is 20 degrees Celsius, you are happy with my sentence. But when I tell you I paid 20 riyals, you usually ask me حال من؟ الجملة فيها شيء ناقص، صح؟ أنا دفعت 20 ريال، زين 20 ريال حال من؟ أو أنا استلمت 20 ريال، طيب 20 ريال استلمتها من؟ Or when I say the wind speed is, the wind blows at 20 kilometers per hour, you're like, okay, where? Where from? Where to? So you need a number plus a direction plus a unit, which is what we call a vector. Now, things like time, temperature, mass, these are all scalars. You give a number and a unit and no one's going to ask you more questions because you have answered the full question, okay? But other things like velocity, momentum, acceleration, these things require a direction, and we have already touched upon this. Remember when we spoke about in the lecture, in the previous lecture about acceleration, and we said the rule about acceleration is that if acceleration and velocity are in the same direction, then the object speeds up. If they are in opposite directions, then the object slows down. We have already used the concept of vectors there because we spoke about them being in the same direction or in opposite directions. Now, graphically, we can represent vectors as arrows. So this, for example, is a vector 6 kilometers north. We have a number, a direction, and a unit. 4 kilometers south, number, direction, unit. And we write it either as, we can write a vector in 3 ways to differentiate it from a scalar. So we can write it with an underscore or with an arrow on top of it, tiny arrow, or we can make it bold. Now, bold is easy to do on a computer, but not as easy to do when you're writing. So when we're writing, we usually stick to the superscript tiny arrow or subscript underline. We do not, and I'm going to write it this way, we do not just put a dash on top. Do you know what a dash on top means?
Average velocity.
Yep. So a dash on top is average or mean, not only velocity of anything. In statistics, if you put a dash on top of something, it means the average value. So if you put it on top, it has to be an arrow, not a dash. Now, as we said, a vector has a number and a direction, right? The number is what we call magnitude. And we represent it by putting these two lines, two walls, between to the left and to the right of the vector, okay, to denote that this is only the magnitude component, and there's a direction component which we're not writing. So the magnitude of 2 is 2. The magnitude of -2 is also 2. So you don't look at the direction. You just look at the number. Here's a question. What is equal to 2?
2.
Okay. So number equals number. Nice. Simple.
1 plus 1.
Okay. So again, number plus number, right? Okay. What about vectors? When do we say two vectors are equal?
2 minus
When
2.
they have this
When
the same direction,
Direction and
they
magnitude.
have same direction.
you can keep it.
Excellent. Excellent. All of you are excellent. You need to have both the same number and the same direction for it to be equal. Okay. What about this? Are these equal?
No.
No.
No. The directions are opposite, right? Okay. What about this? Are these two equal?
No.
So someone said no. Sorry, you were saying something? Someone was speaking, I couldn't hear you.
What is the direction?
Very good question. Here I am asking a very stupid question because this is not even a vector. I have just drawn two lines. A vector needs a direction. And if I don't give you a direction, then there is no meaning for me asking if it's equal or not, because this is incomplete information. I do not know. Okay? And this is something that when we look at it as a graphical representation, most students are able to grasp the idea of, this is very simple idea, ma fi ittijah, it's not a vector. But when we come to writing it down, most of us, not only students, even instructors, many times they forget the direction part. So you see people write something like, now this is the same as writing velocity equals 20 meters per second. What's the problem? What's the problem in what I wrote? Is there a problem in what I wrote?
Yes,
Okay, what is it?
the sign, positive or negative.
Sign, positive or negative. Or if I don't want to put a sign, I need to write something like
Direction.
direction, like north,
North.
or south, or at 50 degrees from x-axis, or
Right.
to the
Or left.
right of my home, something like that. Yeah. So see, most people very easily recognize that graphically this is not a correct representation of vectors. Yet when writing it down, most people usually forget about the direction part. They simply write the unit, the number, and leave. So keep this in mind. Okay. Now let's look at addition. There are two ways to add vectors. One is using graphical methods, so by drawing, and another one by using analytical methods or component method, and that is mathematically by writing it down. And we're going to look at both of them, okay? Sorry. We're going to look at both of them in this lecture. We'll start with the graphical method, which most students find easier, but I actually find more difficult. Let's say this person is moving east by 8 kilometers and then moves further east by 6 kilometers. If I want to show the total displacement of this person, how should I show it?
Just add the two.
Okay, and show it how? Display it how? How do I draw it?
14 kilometers.
One line.
Yeah, so one line, 14 kilometers, right? East.
Yeah.
Simple. Okay. What about now? He went 8 kilometers east and then 6 kilometers west.
2 kilometers.
2 kilometers east.
2 kilometers east. Simple enough? Simple and nice, right? Okay.
Right.
So we looked at the display. We spoke about displacement before, and today we define it as a vector. Displacement is a vector, and this is why we treat it in a different way than distance. Remember, when distance we went 10 this way and 5 this way, we would say distance is 15. But 10 this way and 5 this way, we call it 5 displacement. And the reason we treat them differently, although we did not speak about it explicitly before, is because they are vectors. Displacement is a vector. Okay? And when we're asking about the displacement, we're looking at the resultant displacement. So, what about now? Everyone knows this guy. Moves to the right, then goes up. He goes east, then north. Now, how do I define the displacement?
A squared.
Equation.
Okay, equation. Okay, so you're saying Pythagoras because this is a right angle and we can do this, right? And we can find the hypotenuse using Pythagoras. صح?
Yes.
Okay.
Yeah.
Lubna in chat has said something. She's saying from the tail of the first vector to the head of the last vector. So from here to here. Okay. So when we're looking at Pythagoras, what if I have this instead? This is the first vector. This is the second vector.
We define by equation by I and J.
Okay, we can do it by I and J. Yes, that is the vector component. Or we do what Lubna said, and we say from the tail of the first to the head of the last, this way. Okay, because we cannot use Pythagoras if we don't have 90 degrees.
By angle.
Yeah. Okay. Well, we measure the distances. Now let's do it graphically. What we can do is, what's the problem here? It's stuck. Okay. Pythagorean theorem. This is what you all said. Excellent. Okay. But is it enough just to use Pythagoras theorem and give what is D? Or do we need to do something else?
Direction.
The direction.
We need the direction, right? Now on a graph, it's very easy. We drew it, so the direction is obvious. But we still don't know, because this one we can easily say 10 east. This one we can easily say 5 north. This one, we can find the number, but in what direction?
Angle from x-axis.
Okay. So we can give it using an angle. Now from geometry, okay, we can simply do, this is my opposite. If I'm looking at this angle, this is my opposite, this is my adjacent, this is my hypotenuse. I can use tan of opposite over adjacent to get my angle, right?
Yes.
Okay. Can I use this angle instead? Can I use the angle alpha instead of angle theta?
No.
Yes.
No.
No. Yes. No.
Yes.
Another
Okay.
yes. We have 2 and 2.
Yes, we
But you
can.
have to define it.
Yes.
Yes, we can.
No.
Can
Okay, so we have almost an equal numbers of yeses and nos. Sorry. I have a problem with my ear today. Okay, so we can use both. We can use theta and we can use alpha. The only thing is definitions of sines, cosines, tans differ. That is why when we say angle 27 degrees, it's not enough. Okay, so this is 5 and this is 10. Okay, tan inverse of 5 over 10 will give me 26.6. Yes?
Yeah.
But that's not enough. Saying angle 27 degrees is not enough. I need to be very, very explicit.
From
Okay.
x-axis.
Okay, that it is 27 degrees from the positive x direction. Okay, or if I use the angle alpha, then I need to be very explicit that it is blah degrees from the positive y axis. Okay, all right. With numbers, we do something that we never think about. We say 5 plus 6 equals 11, and 6 plus 5 also equals 11, right?
Yes.
Right.
There's something that we do here that we never think about. That it doesn't, the order doesn't matter. 5 plus 6 and 6 plus 5 don't matter. Yeah?
Yes.
Now, with vectors, again, it doesn't matter. It's absolutely fine. Okay, you do A plus B or B plus A. It's exactly the same thing. Let's do the actual triangle method. Why is my phone not shutting up? Okay. Now, the tail to tip method of adding vectors is what we call the graphical method. And what we do is we say, okay, we will take the first, what's it called? We will take the first vector this way. And then we take the second vector and draw it after it. And we take the initial point to the final point, and we end up with this. Right? What if I do it in the opposite direction? I start with this, then I go with this. I will still end up with something in the same direction. So D1 plus D2 or D2 plus D1 give me the exact same result. Okay. And this thing we call, this property we call associative process. Okay, so vectors are associative. A plus B or B plus A give us the same result. So let's do another example with 3 vectors. We start this way. We add the second one. We draw the third one. And our resultant vector is from the very beginning point to the very last point. That is our resultant vector. Any questions so far?
ايوه دكتور،
أيوة.
المثلث اللي قبل هذاك ما فهمت كيف ناتيه، نسوي التان ولا نظرية فيثاغورس؟
أي واحد هذا؟
لا بعد اللي قبل. ايوه هذا.
هذا؟
ايوه
هذا تقدر تستخدم تان. فيثاغورس تقدر تستخدمه إذا كان رايت أنجل. إذا ما كان رايت أنجل ما تقدر تستخدم فيثاغورس. يا إما إنك ترسمه كيف ما نحن بعدين سوينا بالرسومات وتحسب الزاوية، أو إنك تسويه عن طريق الحساب الكومبوننتس ميثود اللي بنسويه بعد شوي.
يعني إذا كان مثلث قائم الزاوية نستخدم
أيوة.
عادي نظرية فيثاغورس. إذا كان ما قائم الزاوية، إذا ما قائم الزاوية نستخدم اللي هو الساين على الكوس اللي هو التان.
التان راح يعطيك الزاوية، ما راح يعطيك الطول. انت عندك شيئين، عندك ماجنتيود ودايركشن، صح؟ التان راح يعطيك الزاوية، هذه الزاوية او هذه الزاوية، لكن ما راح يعطيك طول. حال الطول لازم يا اما نحسبه measuring على جراف على رسمة، او انه نعمله كالكوليشن باسلوب معين. Okay.
ايوه خلاص.
Okay, we'll do a couple of examples which will make it clear now. Okay, let's all go to Moodle and start with the first PIQ. Okay, so the first one is up. And what we're doing is we are adding 3 vectors together, A plus B plus C. What is our resultant vector? Let's give you a couple of minutes for it and see what we get.
دكتور صوتنا واضح.
قطع الصوت دكتور.
Sorry, I was recording a voice note. That's why I was on mute. Okay. Time is up. Alhamdulillah.
يرحمك الله.
يرحمنا ويرحمكم جميعا. Okay, let's see how many people actually responded so far. Did you guys answer?
Yes.
Yes.
No. I think Moodle is being stupid. Okay, there we go. يتدلع موديل اليوم، لازم نعمل له ريفرش.
ما بس اليوم
متعب، خصوصا لما الكورس كبير في 300 نفر 400 نفر. It's very very slow. بعد حالكم شوية أسرع، لكن نحن لما نجي نفتح مثلا نعمل الكويز أو نعمل البي اي كيو أو ما شابه، نكتب الأسئلة، بالنسبة لنا جدا جدا متعب، لأنه أول ما نحن نجي نفتح تلودز 400 يوزرز، علق 5 دقائق لين يفتح. Okay, let's see. Most students answered C, and the second most was B. Let's see. Let's draw it together. So we'll do it using the graphical method. A, B, C. My initial point is here. My final point is here, which means my result is in this direction, which is C. Salim, try refreshing the next time we open a question. Sometimes Moodle is just stupid. Okay. Hajar. You can do it in any order. Remember, we said it's associative. Let's try a different order. I will do.
مستر
أيوة.
الحين يوم رسمنا هذا طلع معي مثلث أنا يعني ما عارفين كم طوله بالضبط.
بعدد المربعات. Sorry, give me a second. Someone keeps calling. السلام عليكم. الحمد لله، كيف الحال عمي؟ ايش اخباركم؟ طيبين؟ حياكم الله. حياك الله، ايش اخباركم؟ طيبين ان شاء الله.
دكتور الصوت.
Sorry about that. Let's go back. Okay. Let's do it on the whiteboard. Okay? Sometimes doing it is easier. That's the wrong one. Let us try again. I want these things, and I want them here. Yay. Okay. So we look at the number of squares. So A is 2 squares down, B is 2 squares right, 1 square up, C is 3 squares to the left. Now, if I start by A, B, C, I will end up with, this is start, this is end. We end up with this. Yes?
Yeah.
Let's try CBA. Okay, let's try CBA. راح أبدأ من هنا. C B. أنا أستخدم نفس الألوان مال المرة الأولى A، والناتج نفس الشيء. طيب خلينا نجرب بعد واحد، يمكن أنا أقص عليكم. خلينا نبدأ B. B إيش تريدوا، A ولا C؟
A.
A. وبعدين إيش بقى لنا؟ C. C. بدأنا من هنا، انتهينا هنا. النتيجة دائما نفسها. هذا اللي قلنا أنه vectors are associative. A B C. Okay, C B A B A C B C A. In addition and subtraction, vectors are associative. It doesn't matter. The order does not matter. Okay. What about subtraction? How do we do subtraction? In subtraction, we do again something that we've always done, but we've never thought about it. What is the difference between these two?
The same.
They're the same. في كل الأحوال الجواب واحد. 3 minus 2 is the same as 3 plus minus 2. صحيح؟
صحيح. أيوة.
خلنا نجي هذه القاعدة ونطبقها على الفيكتور. Say I have a vector D بهذه الطريقة. What is minus D?
The opposite direction.
Other direction.
Same length, opposite direction. صحيح؟
صح.
ممتاز. Say I have a vector V بهذه الطريقة. Its opposite is this direction. صحيح؟
صحيح.
Yes.
Okay. Are these two opposite?
No. No.
No.
Okay.
No.
Are these two opposite?
Yes.
No,
Yes, doctor.
But
No.
No.
not same
value.
انتبهوا على شيء. الدايركشن is different ولكن الدايركشن is opposite ولكن الطول ما متساوي. معناته these two are not opposite because one is not the negative of the other. صار في تغيير في الطول.
ما متساوية.
ما متساويات. لازم النمبر يكون متساوي والدايركشن يكون مقلوب. First we define the negative of a vector, we flip it, and then we add the negative vector. Let's try. We want to do V2 minus V1. What do I do? First, what is minus V1?
The opposite side of
It is V1 مقلوبة و V2 ما زالت كيف ما هي. الحين أجمعهم. هذه V2 هذه minus V1. بالتالي النتيجة هي في هذا الاتجاه. اوكي.
ليش ما يكون على تحت دكتور؟
وين دكتور؟
A كان هذه الطريقة و B كان في هذه الطريقة صحيح؟ قلنا A minus B المطلوب صحيح؟ هذا minus B. تمام؟ نجمعهم A minus B. بدأنا من هنا انتهينا هنا، بالتالي صارت كذا. إذا سوينا minus B plus A أيضا ممكنة. نبدأ ب minus B plus A. بدأنا من هنا انتهينا هنا، أيضا صارت في هذا الاتجاه. وضحت الفكرة؟
ايوه دكتور.
Yes.
يعني بدال ما تسوي 3 minus 2 انت هنا جالس تسوي 3 plus minus 2. نقلب أول وبعدين نعمل الجمع.
يعني دكتور نشوف نقطة البداية أول شيء، لا؟
أيوة
علشان نحدد يعني اتجاه السهم.
أيوة، من البداية للنهاية.
اها اوكي حلو.
طيب زين. Let's do an example. I'll skip up the IQ. 3 vectors A, B, and C are shown in the figure. Let's draw the vectors. What is A plus B? And what is B plus B minus C? خلينا نبدأ أول شيء A plus B. وين بيكون؟
كوادرانت.
نرسم هذا A، بجيب B. B هو 4 لليسار و2 فوق. ف2 فوق 1 2 3 4 لليسار، معناته بهذه الطريقة. يعني هذه هي نقطة النهاية. من البداية للنهاية هذه هي النقطة. صحيح؟
صحيح.
خلينا نشوف. وهو كذلك. وهو كذلك. طيب خلينا نروح على B minus C. أول شيء إيش نسوي؟
نقلب سي.
أول شيء نقلب C. طيب سؤال، كيف أقلب C؟ هل أقلب C بهذه الطريقة ولا أقلب C بهذه الطريقة؟ هذا واحد وهذا
نفس
اثنين.
الشيء.
نفس الشيء. طيب
ما
زاوية غير.
أول
اثنين.
واحد.
نفس الدايركشن، نفس الماجنتيود عادي.
ثاني واحد.
ايش
نمبر 1 نمبر 1.
نمبر
انزين.
2.
لما نسوي بالجرافيكال ميثود ما تفرق، لانه في نهايه المطاف انا باخذها وبجيبها هنا، صح؟ وبتكون هذه هي الريزلتنت مالي. لكن لما نيجي نشوفها من ناحيه رياضيه بحته هذه غلط. اوبس وش صار؟ صبر صبر صبر، صلي على النبي، ليش مستعجل؟ انزين، من ناحيه رياضيه بحته رقم 2 خاطئ. ليش؟ انا بقفز شويه بجيبكم على سالفه الكومبوننت، ولو اننا بنسوي الكومبوننت بعد شويه، ما سويناها بعد. اذا اريد اوصف سي بشكل رياضي، ايش اسوي؟ اقول سي عباره عن، خليني امسح هذا عشان تكون واضحه. زين، بكتب هذا هنا. بقول سي عباره عن اننا، هي بما انها متجهه في هذا الاتجاه، سي عباره عن انني انا رحت لليسار مربعين وبعدين نزلت تحت 3 مربعات، صحيح؟ I went 2 squares left and 3 squares down. So x is minus 2 and y is minus 3. صح؟
ايوه
صح.
Okay. Now if I want to take the opposite of that, what is minus x and what is minus y?
2 and 3.
2 and 3.
2 and 3. Now if I want to do 2 and 3, 1 2 1 2 3, it has to be in this direction, صح?
Yeah.
If I put it here, although it's the right magnitude and the right thingy, but it does not conform to these. right?
Right.
So, mathematically speaking, this is the correct one. But we'll come to this back in a bit. So, I define minus C. خليني أمسح هذه الخرابيط عشان تكون واضحة. زين. I define minus C. وبعدين أجيب minus C هنا. And this is my resultant vector in blue. هل وضحت الفكرة؟
Yeah.
Okay, excellent. Now. أيوة.
ايش كانت الطريقة الثانية اللي تنفع من ناحية جرافية؟
كيف؟
قبل شوية شرحت طريقة وقلت هي فقط بالجراف تنفع، بالماثيماتيك ما تنفع، ايش كانت؟
هذه أنني لما أقلبها أحطها في نفس المكان.
اوكي.
لأنه من ناحية جرافية ما تفرق، أنا في كل الأحوال تراني بنقلها هنا بهذه الطريقة. طيب. Let's do one which combines both addition and subtraction. 3 vectors A, B, and C are shown. Which of the vectors at the bottom is A plus B minus C? And because the best method of learning is teaching, we will do it in groups and breakout rooms. Moodle is stuck again. Go to question 3. Go to question. Okay. I will say about 3 minutes should be enough, given why is it so slow? Breakout rooms. Okay. So I'll set the timer to about 3 minutes.
دكتور ما ظهر عندي.
الحين بيظهر ثواني. The system is very slow. Okay, ready? And here we go. Refresh the page if you can't see it. Okay, so let's see how it went.
دكتور ظهرت معنا نفس المشكلة قبل.
كيف؟
ظهرت نفس المشكلة، ما يظهر السؤال معنا.
طيب اعملوا لي شيء، اعملوا لي سكرين شوت ايش اللي يظهر عندكم في الشاشة بالضبط، وارسلوا
طيب.
لي الايميل عشان اشوف مع CET ايش هي الاشكالية.
يظهر you have no tries left for this question.
No tries left. هل انت
أيوة.
جاوبت اصلا؟
ايوه مجاوب. السؤال اللي قبل جاوبت، بس السؤال الثاني ما رضى يفتح.
ويقول لك there is no tries left.
ايوه
ايوه دكتور نفس المشكله.
حاولوا تعملوا ريفرش.
سوينا ريفرش دكتور اكثر مره بس ما طلع.
اوكي خليني اشوف ايش الاشكاليه.
تأكدوا يمكن عدد الويك، أي ويك،
لانه انا يبين عندي انهم 118 شخص داخلين، اللي هو عدد الموجودين في هذا المحاضره بلس اور ماينس. ايوه صحيح. ما اعرف ايش الاشكاليه. number of not responded 5 people have not responded، يعني 115 شخص جاوبوا بدون اشكاليه. Let's see. I will try my best to fix it for next time. طيب. Okay, so out of 115 people who answered, 105 people answered B. هذا نسميه اكتساح بمرتبة الشرف. And the correct answer is indeed B, which means that we have all understood how to do this, and I am very, very happy about that.
دكتور
ايوه
مسوي بريزنت للسكرين.
الحين مفروض يكون صار بريزنت. شوفوا السكرين
ايوه
الحين.
صار.
اوكي
الحين
طيب ممتاز. هذا C minus C في هذا الاتجاه، بالتالي كان عندنا A B minus C. بدأنا هنا انتهينا هنا، هذا هو الجواب. B هي الإجابة الصحيحة. أحسنتم. طيب when we multiply a vector by a scalar, what happens to it? If I have a vector A and I multiply it by 5, what happens to it?
It's become longer.
5 times bigger.
Okay, 5 times bigger. What about the angle? Does it change by 5 times?
No.
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 The angle stays the same. What if I multiply it by minus 5?
The direction change also.
Good.
The
So
angle
it will
changes.
be bigger, and then it will flip by 180 degrees.
180
right?
Yes.
Excellent. Can you see my photo, by the way?
Yes.
No.
Yes.
Okay.
No.
Okay. Okay. No means you are your settings are allowing only one video at a time, or that it is showing you the presentation as your main thing. It's okay. As long as you see the presentation, I don't look that pretty. That's fine.
دكتور إذا تقصد شكلك ترى كنا ظني ما نشوف.
Oh, okay.
ايوه حتى انا عندي.
Let me see.
لو أحسن.
Okay. انزين. طيب. No, go back. Okay. So we multiplied by 2, becomes longer. Minus 4, flipped, and longer. Okay, we come to the mathematical part. Graphic part خلصنا، جينا على mathematical parts اللي هو components of vectors. طيب. الحين احنا اوريدي قبل شويه سوينا شيء، تتذكروا لما كنا نعمل الفليبنج؟ انزين، قبل شويه لما كنا نعمل الفليبنج مال سي وماينس سي، ايش قلنا؟ قلنا أنه في الإكس أكسس هو -2 وفي الواي أكسس هو -3. تتذكروا؟
Yes.
ولما جينا نعمل فليبنج
يس دكتور.
قلنا صار x يساوي 2 و y يساوي 3، بالتالي سويناه هنا. هذه الآلية اللي نحن استخدمناها أنه أخذنا فيكتور على زاوية وفصفصناه إلى x وإلى y، يسمى resolving into components. هذا ليش زعلان؟ أوكي. يسمى resolving into components. زين؟ the x component and the y component. وإذا عندنا 3D ممكن يكون z component، x component، y component، z component. طيب إذا دارسين مثلا spherical polar coordinates، cylindrical polar coordinates في الرياضيات، you can resolve it into any set of coordinates. بس نحن الحين هنا basic course نحن نعمل x y z. إنزين؟ أو حتى z ما نسوي في الكورس x y. طيب Superman going up. It's a plane. It's a bird. No, it's Superman. We have x and y components. Now, if I tell you d is equal to, if I tell you d is equal to 10, and this angle is 30 degrees, can you find what is this length and what is this length?
Yes.
Yes, by sine and cosine.
Using
Sine
tan.
and cosine, صحيح, from trigonometry.
Yes.
Okay. What will be the x component?
10 cosine theta.
Cosine.
Sine theta.
10 cosine theta. And this one will be 10 sine theta. صحيح? And you just resolved it into its components. You just resolved it into components. The 10 cosine theta نسميها d مع subscript x، لأنه هنا اسمه d. إذا كان اسمه smiley face كان بيستوي هذا smiley face x. And this is dy. Okay. Remember when we asked قبل شوية هل ممكن نستخدم ألفا أو لا؟ ممكن نستخدم ألفا؟
أيوه.
ايش اللي راح يختلف لو استخدمنا الفا؟
الساين والكوس.
الساين والكوس بينقلبوا صح؟ اللي كان كوساين، الاكس كان قبل كوساين بيستوي ساين. ساين الفا. والواي قبل كان قبل كان ساين بيستوي
كوزاين.
كوساين. انزين، لكن هل الارقام راح تتغير؟
No.
الارقام ما راح تتغير صحيح؟ 10 كوساين ثيتا is equal to 10 ساين الفا، لانه الفا اصلا 90 ماينس ثيتا. تمام؟ كثير من الطلاب يجونا وقت الامتحانات او هذا يقول لك نحن متلخبطين، الانجل ما اللي نحن متعودين عليه. او كثير من الاحيان يصير شيء اسوء، يجون طلاب ويقول لك يا اخي انا حطيت ساين وكوساين، كيف الاجابه طلعت غلط؟ Do not, and this is very important. إذا كنتوا نايمين حتى الآن، اللي نايم يصحى الحين ويسمع هالجملتين وبعدين أرجع نام أو ارجعي نامي. Do not memorize أنه sin is y و cosine is x. Do not memorize. Always draw the angle on the drawing. إذا ما في drawing, you draw a drawing and put the angle on it. وشوف أي واحد hypotenuse، أي واحد opposite، أي واحد adjacent، وبناء عليه استخدم كوساين أو ساين أو تان. طيب أحيانا في بعض المسائل مثلا بيقول لك في شيء جالس يطيح بهذا الزاوية من فوق من طيارة. طيب الحين أنت الزاوية اللي عاطنك إياها لا هي ثيتا ولا هي ألفا، عاطنك هو مثلا هذا الزاوية من الطيارة. الحين لو أنا أجي أرسمها بهذه الطريقة، زين، انا لا عاطني هو هذه الزاويه ولا عاطني هذه الزاويه، لازم اشوف الكومبلمنتري انجل مالها. صحيح؟
صحيح.
زين، فnever ever memorize the sines and the cosines. Make sure انه you draw it or you check it, and you know how to do all of this. The magnitude is the شو اسمه hypotenuse. Now the magnitude here اذا عندك الاكس كومبوننت والواي كومبوننت، قبل شويه في حد سالني طبعا للاسف لانه وي ار نوت فيس تو فيس، انا لما اعمل البرزنتيشن ما اشوف اسم الشخص اللي يكلمني، اسمع اصوات بس، فاعذروني اني انا ما قادر احفظ اساميكم. قبل شويه في حد كان يكلمني انه هل ممكن دائما نستخدم بايثاغورس، وقلنا لا، بايثاغورس فقط 90 ديجريز، لكن اذا عندنا شيء كذاك اما نسوي كومبوننت او نرسم، ما اتذكر من كان، ما شفت الاسم. طيب هنا we can use Pythagoras لانه اذا انت عندك الاكس كومبوننت والواي كومبوننت by definition they are at 90 degrees, so you can use Pythagoras. And to find the angle theta you use tangent as we said before. ايش هذا الشيء الغريب العجيب اللي طالع لي بدون سبب؟ no do not delete the slide. Do not delete the slide. Bad.
حرق علينا الدروس.
طيب analytical method of addition ايش هي؟ وصلنا اخيرا للطريقه اللي قلت لكم انا شخصيا افضلها. ايش هي؟ Let's say vector C is equal to A plus B. I can draw it. ما اعرف كم منكم شاطر في الرسم، انا ثور في الرسم. انزين؟ حدي في الرسم يوم ارسم بني ادم هو هذا. طيب هذا حدي في الرسم. I don't like drawing. وبعدين sometimes you have a really complicated vector، او مثلا عندك انت لازم تجمع 3-4 فيكتورات، يا اخي كم فيكتور ارسم؟ ما يخلص. There is an easier way. There is a mathematical way. اوكي؟ شوفوا يعني مثل هذا يعني ما تستاهل مثلا تنحط مره جنب الموناليزا في متحف اللوفر.
مفروض.
صبر على الاقل يكون فرحان شويه جنب الموناليزا.
صراحه
تستاهل دكتور.
ما دام راح الموناليزا فرحان شويه، يبتسم على الاقل، بس ما
مش ناقص
ضروس، طرس واحد مكسور من ضروسه. انزين؟ So C equals A plus B. Okay. Here is A and here is B. Now the graphical method is to do what? The graphical method اجي من هنا واعمل رسمه هنا، صحيح؟ طيب لكن انا ما اريد اعمل الجرافيكال ميثود يا اخي. انا ما اريد اعمل الجرافيكال ميثود. طيب ايش اسوي؟ اجيب الاي واطلع ايش الاي اكس وايش الاي واي. استخدم الساين والكوساين اطلع ايش اي اكس اي واي. اجيب البي اعمل فيه نفس الشيء، بي اكس وبي واي، وبعدين اجي اجمعهم كل الاكسات مع بعض. كيف ما نحن سوينا، تتذكروا لما جينا جمعنا واحد هذاك ابو 6 كيلو ابو 8 كيلو وقلنا يساوي 14 كيلو خط واحد طويل؟
Yes.
نفس الفكره، اجمع الاي اكس والبي اكس واجمع الاي واي والبي واي، لانهم كلهم الاي واي والبي واي كلهم في الواي اكسس، كلهم خط مستقيم، والاي اكس والبي اكس كلهم في خط مستقيم، كلهم في الاكس اكسس، والسي اكس يساوي بالضبط هذا. اللهم وبارك، انتهينا. We found it. Now if you have 10 vectors، ايش الاسهل؟ انك ترسمهم 10 vectors to scale on a graph paper، ولا انك انت بالحسابه بسرعه let me find the x axis and the y axis واجمعهم كلهم؟ يعتمد. To me it's much easier to use a calculator. Okay, I want to find the magnitude. Very easy. cx squared plus cy squared, square root. Hypotenuse, Pythagoras. Done. Direction, I already have y and x. Y divided by x, 10. Done. Any questions on this?
دكتور اخر جزئيه.
Sorry?
اخر جزئيه دكتور. ايوه
اي واحده مال هذه magnitude و direction.
ايوه
تو الحين انا لما سويت ax plus bx طلع لي cx صح؟ And when I did ay by I got cy. Correct?
أيوه.
Now, if I have this much in the x-axis and this much in the y-axis, how do I find the resultant vector? How do I find this? This is 90 degrees. Hello.
الرسم يتذكر معي.
We do x squared plus y squared, square root, Pythagoras. So when I am describing something, I'll come to it in a second. When I'm describing a vector, I can do it in two different ways. We'll come to it in a second. There are two ways to express any vector. الحين خلصنا كل شيء، خلونا نلخص المحاضرة كلها. There are two ways to express a vector. This is vector A. I can either هذا المشكلة. I can either use the magnitude and angle, or I can use what we call the unit vector notation. The magnitude and angle is when I say my vector magnitude is 10 kilometers at an angle theta of 26.6 degrees from positive x-axis. The unit vector notation is what? The unit vector notation is what we were saying. I have x equals 5, y equals 10 مثلا. Okay, these are two different ways. Now this is not actually the exact same thing. To be accurate, let me actually do it. 5 squared is 25 plus 10 squared is 100. So 125 square root is 11.2. 11.2 y على x 10 over 5 is 2. So this should be 11.2. Oh, what is the tan inverse of وبنعمل ده ازاي؟ Can someone look at what is the tan inverse of 2?
Uh, 63.43.
63.4. 63.4. So this is the same vector, which I can express in two different ways. 11.2 kilometers at 63.4 degrees, or x equals 5, y equals 10. Now this whole x equals 5 and y equals 10 is not elegant. في طريقة أفضل أنه نحن we express it in. What is it? We call it a unit vector. What's a unit vector? A unit vector has a magnitude of 1 and has a fixed particular direction. What does this mean? We have three directions, x, y, and z, right?
Yeah. Right.
Okay.
Yes,
I will assign three unit vectors to them, I, j, and k. Okay. And these unit vectors point exactly along these axes. Now you might ask me, طيب ليش صدعت الراس هذه? Why all of this headache? Madam, we already have x, y, and z. Why are we bothering with the whole I, j, and k? Let's just use x, y, and z. You want to put a hat on it? Put the hat on the x, y, and z. Make it finish. صح ولا ما صح؟
صح مرة واحدة.
مرة واحدة. ليش مرتين؟ ليش صدعت الراس? Turns out, and this is not in your, this is not in your syllabus exactly, but I want to teach you this because it is very, very important and it is useful later on. Okay. Actually, let me check if it's actually in your syllabus exactly or not, because I mean, aywa.
In the previous slide, is that absolute A?
In the yes, that's absolute A. So there's no minus in this. If it's in the minus direction, the angle will show it's in the minus direction.
Oh.
Okay. So we go back to the question. I just checked it's not in your book. Why do we bother with IJK? We already have X, Y, Z. Why are we doubling the work? Because although we don't use it in this course, okay, mathematically, the idea of a unit vector is actually much, much more important, and it is very directly tied to your chapter on measurements. So let me ask you something. Remember when I gave you the example of that king مع الرجول والمقاسات?
Yeah.
Yeah. Okay. Okay. Now today our unit standard of measurement is meter, صح? Or feet if you are in America. لكن ايش المشكلة? What is the issue if our standard unit was that king's foot? There is no problem as long as we all agree what is the length of the foot. If we all have a photo of the king's foot, or the size of the king's foot, we can all use the king's foot. صح? There's no issue. Yeah.
Right.
Say for example, I want my standard of unit to be this. 1 blah. Okay, what is this? It's a checkbook. Okay, 1 checkbook is my standard of length. Is there an issue in it? No. When I come to measure something, I will say, okay, 1 checkbook, 2 checkbooks, 3 checkbooks. By now I'm very rich. I have 3 checkbooks. Okay, but the idea is I can choose my unit of measurement. Now this IJK being in the direction of XYZ is my choice. I can choose it not to be in XYZ. And I will give you one example which we will later on in the course use a lot, but which we will never formally define. Okay. So a unit vector is defined defined as how do I write the formal definition of it? Okay, so a unit vector I is defined as the vector I over the modulus of the vector I. Okay, so I take the total length of the total vector and I divide it by the total length of the vector, and I get a unit, a standard unit of measurement. Okay, now let me give you an example. Say for example you have a problem, which we will do this kind of problems later on in the course, where we have a book or a ball going up a slope, up a ramp. Now where's my x-axis and y-axis? Anyone?
x-axis is
ايش دكتور؟
قاعدة والارتفاع y.
This is x, this is y, صح؟ لكن لما نجي نحلل القوى بعدين فيها all the forces and accelerations, you will find that everything is at a stupid angle to my xy axis. Which means for every calculation, I need to do sine, cosine, sine, cosine, sine, cosine. راسي عورني. What if, bear with me, crazy idea, what if instead I choose my IJK, instead of being along the XY axis that are like this, I choose this direction to be I, this direction to be J. What happens then? Suddenly, I have redefined my IJKs so that my fixed directions, my unit vectors are in a very easy direction. I don't need to deal with sines and cosines anymore. I simply add them like numbers. Do you get an idea of what is the power of unit vectors? Why is it important? Yes. Yeah. Okay. So in this course, we will mainly use it with X, Y, Z, but they're actually much more powerful than that. So we take any vector, and instead of before we wrote X equals 2, Y equals 3, now we write A equals 2I plus 3J. ومعروف I is with X, J is with Y. خلصنا. Okay. We want to subtract. We subtract the components. AX minus BX, AY minus BY, AZ minus BZ. We want to add. We add them the same way. We want to multiply by a scalar. We multiply by a scalar the same way. We multiply each component by the scalar. But what if we want to multiply two vectors? What do we do then? For components. If we want to multiply two vectors, it's a little bit more complicated. And for that, we will do it in the next lecture, inshallah.
Reading a quiz.
What about it?
This idea. Let's multiply two.
Yes. Yes. So we are starting to look at some items which are starting more to become a bit more complicated. I see someone has commented يدور بالراس. Okay. And it does. But the good news is once you get used to it, it then becomes much easier to do all the rest of the problems. So yes, it might be boring at this point, but I promise you it does become more exciting over time. And I promise you these things do come handy. We're not just doing it because we are very bored. Okay. Okay. Let me see the questions. First, I will stop the recording so it doesn't become a huger file than it is at the moment.
دكتور
أيوة.